Sanjana, and this is my assignment 1 presentation for the course Automata Theory and Computation. So the title of this assignment is the MiniATC Language Processing System. The main objective of this assignment is to understand how the automata theory is used in the real programming language processing. So systems such as a lexical analyzer and parser. So for this assignment, we were given a small custom programming language called MiniATC. And the MiniATC supports a simple programming which constructs such as variable declaration assignment statements and print statements as well as an arithmetic expressions. So the language contains the keywords such as begin, end, int and print. So it also supports an operators like addition, subtraction, multiplication, division and assignment operator. So this assignment, it contains 3 levels. So the level 1 is to identifier recognition, level 2 is to lexical analyzer, and level 3 is lexical analyzer and parser using the context free grammar. So now I will explain the each level one by one. So this is my identifier recognition code. So the objective of level 1 is to check whether a given string is valid identifier or not. So according to MiniATC language rules, an identifier, it must starts with a letter and the remaining character, it can contains a letter or an digits. So for example, a valid identifier means it should start with the letters like any of the name or X or total. So for invalid identifier, the example means it will be started in the letters, then it will be not a letters, it will when it started when it start with numbers or any character, any special character, then it will be an invalid identifier. So to implement this task, I use the concept of finite automata. So the logic used in this program is the first character is checked using an is alpha, means if the first character is not a letter, then the identifier will become an invalid. Next, then the remaining characters, then it is checked using is all num, means if any special symbols occurs, then the identifier becomes an invalid. So the program, it finally prints an valid identifier or invalid identifier. So now I will show an output. So if I run this, so then I should enter an identifier. If I enter any string which contains the letters, for example sum, then it will return a valid identifier. Next, so if an identifier contains numbers starting only, so like this, so then it will print an invalid identifier. So it can contain, so that the string may contains letters first, then followed by numbers, then it will show a valid identifier. So this level demonstrates the basic concepts of token recognition using the finite automata. Next, coming to the level 2, that is lexical analyzer. So the objective of level 2 is to implement a lexical analyzer for MiniATC language. A lexical analyzer, it is the first phase of the compiler. So its job is to scan the source program and divide into meaningful tokens. So the lexical analyzer identifies the keywords and identifiers, numbers and operators as well as delimiters. So the MiniATC keyword, they are begin, and int and print. These are the keywords of MiniATC program. So the operator, it can include an addition operator, subtraction operator, multiplication, division as well as assignment operator. So in this program, the input is scanned. It is a scan character by an character. So the function like is alpha. Here is alpha and is digit. They are used to recognize the identifiers and numbers. So conditions are used to identify an operator and delimiters. So for example, if the input of the program, if I give an begin and I will initialize and declare an x, then I will print it and ends with end keyword, then it will be an a valid identifier. I will show the um, so if I give an program, it will identify the keyword you are using this, and then it will sees the it is a letter or an digit using the digit functions and all here. Then it will also then it will also sees the operators, which what and all operators are present in that, and also the delimiters. And next in the main program, I will print the it is a valid MiniATC identifier and or invalid. So for example, if I give, so I have to enter a MiniATC program. So I will enter begin and int x with a semicolon. So then x I will initialize with 10. Then I will print an x with semicolon. Then I will give end. So then it will shows me what and all I have, means like what are the keyword I have, like begin keyword, int keyword, then identifiers are x, next the delimiters are semicolon here, next the numbers are 10, operator it is given like assignment operator, then the keyword print is also an keyword, next the delimiters are parentheses, then next the keyword is end. So this is what the lexical analyzer do, and it will shows an valid MiniATC input. So if I give like this, then yeah. So here I have given an invalid token and I missed an keyword called end. So then it will return an invalid MiniATC input. As the here it will shows that invalid token, that is a dollar symbol. So this is how the lexical analyzer works. So next, so this level demonstrate how the lexical analysis as well as the tokenization concept. So now we will move to the level 3. So level 3, that is the lexical analyzer and the parser using the CFG. So level 3, it is the advanced part of this assignment. So the objective is to design and implement both lexical analyzer as well as the parser that verifies whether a MiniATC program is grammatically correct using the context-free grammar. So CFG, it stands for context-free grammar. So so CFG defines that syntax rules of the programming language. So it gives an grammar for MiniATC, which includes the rules such as program should produce begin and followed by the statement list and followed by end keyword. So the statement, it can be a declaration statement or assignment statement or as well as the print statement. So the expression, it can contains the identifiers, numbers, operators like addition operator, assignment operator, multiplication, subtraction, or division operator. So to implement, and also it can have a parenthesis also, like delimiters. So to implement the parser, so I used an recursive descent parsing. So in recursive descent parsing, so here each grammar, the rule is implemented as a separate function. So the function it is used in my program, it include an program as well as like a program here, and then so use the functions called program and as well as statement list, statement, declaration statement, and assignment statement, and the term and the factor. Print here is the print statement. It is the factor, and parse id function. Next, yeah. Next the expression. Next assignment statement, print statement, yeah, etc. So this program functions checks whether the input starts with a begin or ends with an end keyword. So the statement list it processes and multiple statements, and the declaration statement it statement it checks variable declaration, and the assignment. So here the declaration statement is it checks the variable declaration. So next the assignment statement it checks the assignment and the expression also. Now next the print statement it checks the print statement. Then coming to the expression term as well as factor, these are used for the arithmetic expression parsing and operator preceding handling. So for example, the following input I will give here. So here I given an example program to check whether this program is valid, and it checks as parser grammar structure or not. So then yeah, it is a valid MiniATC program. So the parser checks the grammar structure of this and it prints an valid MiniATC program. So for invalid, if I give like this program only with missing an keyword and or semicolon, then it will print an invalid. So now if I miss any semicolon or anything semicolon or here, then it will give an invalid MiniATC program. So this is the level 3 invalid output. So the level 3 demonstrates the practical implementation of lexical analyzing, parsing, context-free grammars, and the recursive descent parsing. So overall, what is the outcome means, through this assignment, I understood how the automata theory concept are used to compile the compiler designs, and I learned of finite automata, lexical analysis, tokenization, as well as context-free grammar, and also the recursive parsing. So the next I learned how the programming language are processed internally by compilers and interpreters. So thus all these three levels of this MiniATC assignment, it were implemented successfully. So this assignment helped to understand the practical application of automata theory of the real world programming language processing the systems. Thank you.